Hi, I'm Ben Sigmund, a product manager here at BUCHI, and today I'll be talking about our line of laboratory rotary evaporators. BUCHI commercialized the rotary evaporator, or Rotavapor, in 1957. The Rotavap has since gained popularity as a laboratory staple for distilling solvents, typically to concentrate samples. Since its introduction, several generations of the Rotavap have been developed to meet the needs of researchers and flavor enthusiasts alike. Currently, BUCHI offers two models of bench-scale Rotavapors, the R-100 and R-300. The main components of a Rotavapor are the tower, drive, and bath. The tower has a lift for moving samples in and out of the heating bath, which provides thermal energy needed to drive evaporation. When viewed as a system, a vacuum source, ideally regulated by a controller, connects to the condenser to reduce pressure and make evaporation more favorable. Depending on the style of condenser, a chiller may be connected to a coil condenser or a cold trap, which would be filled with dry ice and a suitable solvent like acetone or isopropyl alcohol. In either case, the condenser removes thermal energy from the solvent vapor, which was evolved by the heating bath. The R-100 can be configured with two condensers, a vertical V or cold trap C condenser. The R-300 has 8 condenser options to match the application with possibilities for customization. The R-300 has an electronic hand lift with adjustable lift depth limiter. The R-100 has a manual lift without a depth limiter. The R-300 has options for a 5-liter water and oil bath that can heat up to 95, 180, or 220 degrees Celsius, provided a suitable heating media is used, or a 1-liter water bath, which may be set up to 95 degrees Celsius. The R-100 has a 4-liter water bath, which can only be set up to 95 degrees Celsius. The I-100 interface serves as a vacuum controller, but cannot control other parameters. On the R-100, each variable requires interaction on the respective peripheral. The R-300 pairs perfectly with the i300 or i300 Pro interface by bringing all process parameters to one central controller. When connected to an i300, simply pushing start once will heat up the bath, cool the chiller, pull vacuum, as well as rotate and lower the evaporating flask. The i300 Pro records run data to an SD card and even has the option to program methods for reproducible results when handling samples of similar composition without manually adjusting parameters every distillation. The i100 regulates the V100 with on-off control, meaning the membranes pump at full speed until reaching a set point when they stop pumping. Conversely, the i300 and i300 Pro regulate the V300 and V600 by speed control, meaning the membrane speed slows down as the system nears the set point, creating a gentler evacuation and quieter operation. For more information on how the i300 Pro and i100 control our membrane pumps, check out the video, Operating Modes of BUCHI's V300 and V100 vacuum pumps. Besides the various glassware accessories available to both systems, like flasks or various stopcocks, the R-100 does not have any accessories to automate distillation. The R-300, on the other hand, can connect to an Autodesk sensor, which measures cooling temperature and vapor temperature, automatically adjusting the vacuum to drive distillation. There's also a foam sensor available to replace traditional bump traps, which will automatically send an aeration burst to suppress foaming samples without completely ending a distillation. Check out unattended distillation of a foaming sample to see it in action. The R-300 and R-100 both fill a critical role in the lab. In essence, they follow the same physics to remove solvent from samples, applying heat to samples under vacuum, allowing for a gentler and more efficient distillation. While the R-100 performs the essentials, the R-300 is modular and allows the user to add accessories to expand functionality.